and egg fries at 70 degrees Celsius.
But what if I told you that the universe began with a recipe 57 billion times harder? Welcome to the Big Bang's kitchen, where the first dish ever cooked was Quark-gluon plasma. We are aware of 3 states of matter: solid, liquid, and gas. But few people know there's a 4th state called plasma.
To understand plasma, we first need to break down an atom.
An atom is made up of electrons surrounding a nuclei made of protons and neutrons, also called hadrons. Inside hadrons, we find the most basic building block of matter, quarks held together by particles called gluons.
Think of plasma as a very extravagant dish, a gas so hot that electrons are stripped from atoms, forming a soup of nuclei and free electrons, like the one that makes up our sun.
Quark-gluon plasma is an even more complex cuisine, where matter is so densely compressed that also protons and neutrons are broken apart, forming both quarks and gluons. But there's a secret ingredient for this recipe. An energy powerful enough to break the strong interaction happening between quarks and between protons and neutrons. But what is a strong interaction?
Strong interaction is a fundamental force that binds particles together.
Unlike electromagnetism or gravity, strong interaction does not weaken with distance. In fact, the potential energy in this interaction grows linearly with distance, meaning that it needs another almost infinite energy to break it. For the first 10 microseconds into the universe's existence, at 4 trillion degrees Celsius, this interaction was absent, making quark-gluon plasma possible.
So when my Inca ancestors revered the sun as a source of life, they weren't far from the truth.
Because their story does begin with a type of plasma, an unimaginable energy condensed in 50 square kilometers, from which all galaxies, all of us, and this egg were eventually born.